Okay, so we talked about one type of polynomial, which was the linear function last time. So now we really want to focus on the quadratic for a minute and really delve in a little bit deeper with that. And a lot of this you will have known, a lot of this will be kind of new to you. So if you need to fast forward, pause, rewind, again, remember that you can do that at any point in time. All right, so quadratic, remember this is a polynomial that has a degree of 2, meaning that biggest exponent there on any x is a 2, all right? And we have graphed so very many quadratics, and we have talked about some different forms. The most common form of our quadratic is in standard form, and that is where we have ax squared plus bx plus c, right? And if you recall, as we graphed this quadratic in standard form, we would find the vertex opposite b over 2a, and we would graph from there, okay? But then we started talking more about some transformations, right? And we talked about a parent graph of the quadratic being x squared. So y equals x squared. And then we talked about as we do things to this graph, as we do things to this equation, it causes some transformations to happen to the graph. So, for example, maybe I had x plus 1 squared minus 3, right? And we know based on our lessons and based on our studies of transformations that this took our parent graph here and it transformed it. It just really slid it because both of these are horizontal and vertical translations. This would take us left 1 and down 3. So if I started out with that parent graph of my quadratic like this, it would cause everything to shift left 1 and down 3, right? And that's the only thing that it's doing. So when we talk about quadratics, we have something a lot of times, and I want you, before I show you that actually, let me just say this. If this is our parent, this is just x squared, right? This point was 0, 0. If I slid that point, oh my goodness. If I slid that point left 1 and down 3, this point becomes -1, -3, right? That vertex where it was. And so for that reason, a lot of times we will call this form when it's written this way vertex form. Because it gives us, and it makes sense when we start thinking about our transformations, but it gives us the vertex of our parabola. HK is our vertex, but we have to, my pen is not wanting to cooperate here. We have to do the opposite sign of H and the same sign of K. Okay, so for example, let's say I gave you the equation f of x equals 3 times x plus 2 squared minus 1. Based on what I just told you, the vertex for this one, I take the opposite sign here, so it would be -2, -1. Okay. Now, if either of these two are missing, it would be 0. Okay. And so from here, what I could do is I could go ahead and graph, and I know that -2, -1 is my vertex, and then maybe I pick another point. This is also my axis of symmetry. And then maybe I just pick another x. Let's say x equals -1. I'll just go right here beside it. If I plug that in, I would get 3 times -1 plus 2 is 1 squared. So this would give me 2, right? -1 is what I plugged in. So -1, 2 would be another point on my graph. I would plot that, and then I could reflect, okay? And the connection that I want you to see here is this is exactly the same as if I had transformed this one. It's got a vertical stretch, right? So the graph is skinnier of 3, and then it's shifted 2 to the left, and down 1 because of this, okay? So that's what we call vertex form. And so it's a little bit easier for us to see not only the transformations, but to pull that vertex out of the equation. And so what we're going to do is we are going to take an equation that is in standard form, and we are going to write it in vertex form, okay? So this can be a little bit tricky. This can be a little bit harder than what you are used to. So here's the new stuff, okay? So I'll run through several examples of this with you. But what we're going to do, we learned a technique back in the previous chapter called completing the square. We're going to use that technique, complete the square, to change to vertex form. I know that this is going to be a little bit difficult for you, so follow through. I'll do several examples. It may help you to go back and rewatch this part if you need to, if it's something that is a struggle for you, okay? So we're going to take an equation that is in standard form, and we're going to change it to vertex form. All right, so let me show you how we're going to do that. If we start with something like, let's say, f of x equals 3x squared. Let's do -3x squared plus 6x minus 5. All right, and I'm going to list you some steps over here to the side. You'll want to copy these down and make sure you have them so that as you go through your homework and your practice, you'll have these to reference and you will be able to see what it is you need to do, okay? All right, so the first thing that I want to do is I want to factor out the leading coefficient from the first 2 terms only. And I'm going to put LC from first 2 terms. Okay, so looking here, these are my first 2 terms, right? And my leading coefficient is -3. So what I want to do is I want to say, okay, I'm going to take a -3 out, but I'm only going to take it out of the first 2 terms, right? Leave yourself a little space right here, and you'll see why in just a minute. Close your parentheses, and remember this -5 is still here. All right? The next thing I want to do is I want to find a good C. And if you remember to whenever we were completing the square, we want to find that C that makes us have a perfect square trinomial. Okay? And so to do that, we take the B that's in the middle, we divide by 2, and we square it. Okay? Notice I haven't said to do anything with it yet. Right now, I just said to find it. All right? So if I come over here to my equation, my C is going to be take 2, which is the B, divide it by 2, and square it. All right? So I get 1 squared, which is 1. Okay? Now what I want to do is I want to take that good C and I'm going to add the C to my parentheses. But here's the tricky part, because this is an equation and I have to stay balanced. I'm going to add it inside the parentheses while at the same time I'm going to subtract it outside the parentheses. Okay. Let me show you exactly what I'm talking about here, okay? I've got this equation, okay? And I can do whatever I want to the equation as long as, number one, I do it to both sides, or number two, I keep it balanced. In other words, if I add a 1 here, I've now thrown a 1 in here. I need to subtract that back out so that I haven't really added anything to the equation. But I haven't really added 1. Remember I took this 3 out? What I've really added is negative 3. Okay, so I want to subtract that. Now, because this is a negative here, it's causing a little bit of a sign issue on this side. But what you need to remember is whatever you add in parentheses, you need to also subtract outside of the parentheses. Okay, so if there was a number here, it's got to be multiplied. All right, now, what I want to do is factor and simplify. And we are really almost done with it. So if you understood completing the square, it's just a little extra step. Remember, when we completed the square, we added the good C to both sides. This time, I'm just keeping everything here on the same side, okay? All right, so factored, I have negative 3 times, remember it's the square root of the first sign, and the square root of that good C that I put up there, squared. And now negative 5 and 3 would be negative 2. And that's a minus there. All right, so my vertex here, you see it now looks like vertex form, which was the whole point, is that I get it in that vertex form. So then I can analyze from there. Excuse me. So my vertex here would be opposite sign, same sign. Okay. Let's do one more and see what happens. Let's do... Let's take this standard form. And actually... Ooh, excuse me. I'm going to move some things around. Let me not do another negative leading coefficient. Let's change that. I apologize. Let's do 12 minus 6x plus x squared. Okay, so I do want to make sure that it's in standard form, just so that you can see what happens here and how we manipulate. So I'm going to go ahead and rewrite this as x squared minus 6x plus 12, so I'm in standard form, right? All right, so going back to that list of steps, I want to factor anything out. I want to factor the leading coefficient. Well, here, the leading coefficient is just 1, right? Well, that makes for an easy factor, because that means it's 1 times x squared minus 6x. I'm going to leave a little blank right here because I don't know what I'm going to put there yet, and this plus 12 still sits out here. Okay, so you might want to go ahead and put minus something there so you remember that you need to also subtract it while you're adding it. All right, so I want to find my good C, and so to do that, I take that middle number, which is negative 6, I divide it by 2 and square it, which would give me 9. Okay, so I'm going to add 9 here, but I'm also going to subtract it. Okay, but I'm going to subtract 1 times 9, which is still just 9. So now we factor. That 1 is out there. It's not really, you can put it or you don't have to. I have x minus 3 squared 12 minus 9, well, twelve minus 9 is 3. And now it is in vertex form, and my vertex here would be 3.